my home.
So I've got a strange one here that I've never seen before. Apparently it's quite a common issue, but I've never seen it. So I changed a LED on this Dracula, and when I turned it on again just to make sure that it was all working, I got a error F114 F115, which apparently is quite a common error. I've had a look on PinWiki, and there's a lot of procedures that you can go through to test it, and what I thought I'd do is, as we go through it, I would take you through it as well, and maybe it helps you and helps some others. So I've got my trusty multimeter here, and we're going to get stuck into that. So before we do though, let me show you the issue that actually happens when we turn on the game, and you'll notice that apart from the error message, there are a whole lot of coils that are firing under the playfield, which just gives me a feeling there's something rather strange going on. And so I'm going to turn it on, you hear the sound, and also you'll see the error message. So it just seems some of the coils, the kickouts, so the lower power coils that are misfiring continuously, almost as if it's on a ball search, which is rather strange. But that, along with the error message, F114, 115, so that ball search just continues for a while. And I'm going to get into this and have a look, get the back box off, and we can get stuck into trying to diagnose this issue. I've got the game off again, and let's just get the back glass out. So the first thing I'm going to do is just have a look and see if there are any wires which may have been and connectors which may have been dislodged. And turn the game back on and see if the issue persists. And sure enough it does. So the other thing is, you can't actually get, if you try to get this into test mode, it doesn't work. Okay, so the first step is to actually have a look at the F114 and F115 fuses. So on the driver board, the F115 is the one here over, not in the middle, but on the left hand, 1/3 from the top. Left hand side, and then here on the right hand side, as you're looking at the game, you've got fuses F111 through 114. So 114 is there, and 115 is there. So I can have a look. If I actually have a look at 114, I can see that the fuse is actually gone. So I'm going to pull that one out with the cool little fuse removing tool, which just hooks in underneath the fuse. Just helps. You can also use a screwdriver at the back, and sure enough, that fuse is gone. So I'm going to put another one back. My expectation is it's not quite that simple. So I've got a new fuse there, in there, and that is an 8 amp normal blow fuse. So you've got to be careful you don't put a slow blow but in there. You want an instantaneous fuse blow. So I'm going to put this back in. I'm also going to just have a quick look at 115, and that one actually looks fine, and just test that fuse. I can't see that one looks blown, but I'll have a look on the multimeter, set it to continuity, and check. That works fine. So it's just the 114. So fuse has changed. I'm going to turn it back on now and see what we get. I'm expecting it to go pop straight away, but who knows. It's never this easy that it's just a fuse. But here we go, let's see what it looks like. It's looking promising. Okay. So now it's saying straight into test, and it's just saying a series of the opto switches are buggered. So my guess is that that's just linked to that fuse, because if I look at that fuse that I've just replaced, it's just blown again. That's not it, wasn't just the fuse. It suggests on PinWiki the next thing to do is to test bridge rectifier 1, which is this one over here. So that's what I'll be doing, but you can see all of the optos are done. And the reason why it shows up as this error is because there's apparently within the switch matrix, there's one of the switches is used to determine whether the power supply is correctly being applied to the board, and it's using one of the switches in the switch matrix. When this is out, if there's a problem, it can actually cause a whole lot of sort of other phantom things to show up. I think it's switch 24 that's is used, and so you get the strange results. Let me see if I can go into test. I can't go into test. Clearly there's a problem with the switch matrix because the buttons down on the on the coin door to get into test don't even work. Let me test this bridge rectifier, go to the next set of things to test, and we'll move on. Okay, so there's a tip that they suggest on PinWiki for testing the bridge rectifier without having to take the board out. So the first thing you can do, you put your multimeter on diode test, unplug connector J101, which is over here, and then there's a test point 8 just below the one capacitor here on your driver board, and then take the positive lead and touch it to first pin number 3 and then pin number 7, and you should get a reading of between 450 and 500. So there you go. This one's, it says 460 on here, but it doesn't matter if it's off apparently a little bit. So that seems okay. So if I go to pin 7, I find that I'm getting a rather strange reading which actually counts up. So that's your second test. The next thing you want to do, the third test to check for your bridge rectifier, is by grounding the red wire. So this one you could ground it on to the braid, which is what I've done. Then they say that you need to then test with the black wire again on pin 3. You get the same reading, and pin 7, and you're getting actually a short on pin 7. If I put this on continuity, you'll see it's shorted to ground. So that should not be the case, clearly. So what it sounds like, according to that test, that this bridge rectifier is cooked. So I'm going to take the board out and I'll do a full bridge rectifier test on that. So I've got the driver board out of the Dracula. And this is where the bridge rectifiers are that we're going to have a look at. This is BR2, this is BR1, and I've also got a new bridge rectifier just sitting here that I'm going to test it against. But there's a total of 5 bridge rectifiers on the boards. These two are the ones that commonly have issues. Again, this is your F115 and this is your F114. These are the two that we're looking at. Both of those have been replaced and good. And if we turn the board over, we can see that some work has been done on this board before. So this is the back of the bridge rectifiers. This is these are the two that we're talking about. There's another one up here and another one over there. So let's have a look at the new one to start with. So you can see that you've got, if you look at this closely, you've got one leg which is slightly off center, and then the off of the corner, offset, and then the other 3 legs are set nicely in the corners. So you've got this as sort of an odd leg, odd one out. And when you look on the board, you see the same thing. So on the board, you see 3 legs on each of these which seem equidistant, and then one which is the odd leg, okay, so on all of them. So what you need to do is you set your multimeter to diode, so you can see you put on either side of the odd leg, and you're getting 0.8 there and 0.8 there on the black leg. Then you take the red one and put it on the opposite lead to the odd leg, and then test with the black lead on the ones on the other side. There you're getting 0.49 and 0.49. So this one looks fine. While we up here, let's just do these. Let's just do this one first. So black lead on the odd leg, red on the one on both sides, 0.5, and we've got an issue there straight away. So this one looks like it's a bit dodgy, but we'll test it again. Red lead on this side. It looks like this one's shorted and blown. So this one, bridge rectifier, is gone, which seems to be our problem. Again, while I've got the board out, I may as well check these. So these are the other bridge rectifiers, just for fun. So those readings all look fine. 0.46. Black lead on the odd leg, 0.46. 0.46, red lead, and 0.46, 0.46. Okay, so they all seem good except for this one here. So getting these out is a bit of a problem. They recommend that you take the heatsink off, which is screwed on to the bridge rectifiers, which actually helps them keep cool, hence the name heatsink. So I'm going to start with that, and then, so this is the one I'm going to need to replace, which is BR1, and I'll replace it with this. So while we've got this out, we can test this one as well. So I'm lining it up in the same way. This is the brand new one, so black lead on the odd leg, and on the other side I'm getting 0.74, red leg opposite the odd one, and then black on either side of that leg, 0.78, 0.47 and 0.47. So we're going to take this off to start with. We can just get access to the screws through here, but this is a bit fiddly because it looks like they've moved. And you can actually see now, if I've zoomed in, I've managed to move by just pushing the heatsink down, so pushing it. The legs were a little bit bent, so obviously that's not perfect, but you can see that I've been able to get access to those screws now. I can get the screwdriver in now. And that just comes out quite easily actually. So that's come out. There's your heatsink. That's just popped off. This is the bridge rectifier that I'm trying to get off. Just put a bit of fresh solder on each of the legs that I'm going to be desoldering. The fresh solder and the flux will hopefully mean that when I suck it out with the solder sucker, it comes out nice and easily and doesn't damage the board at all, because it's quite easy to damage the board, damage the traces on these when you're taking them out. So I'm able to get a nice fresh bit of solder on there. I've got the solder gun out, so looks nice and clean. we're done. Let's have a look. Let's see if that'll pop out. You don't want to force it out, but look at that. Out comes the bridge rectifier. That was pretty easy. You can see those legs are a little bit bent. I'm going to leave this one in, but I'm going to give it some fresh solder. Just these look a bit potentially cracked, so whilst I've got this out, put a bit of fresh solder on this. So that's looking pretty good. These holes look nice and fresh. Let's get the new bridge rectifier. Now this is the tricky part, because you're putting a heatsink on it, they've got to be flush with one another. So you've got the bridge rectifier out. You're going to take the odd leg, and you can see you can only get it in one way. You have to bend the legs a little bit to get it in place. Okay, now the tricky part is to get this level, to put the heatsink back on. So I'm going to get some new heatsink compound, but before I do that, I'm just going to screw the other one on because I'm only replacing one. I'm going to screw this one in. Okay. So I've put this heatsink back in, and I've got the legs sticking out. So now what I'm going to do is just solder this in. I'm guessing it's because of the heatsink that this is not the easiest to solder in. I'll pump the temperature up a little bit. Okay, so turn the temperature up to actually to 390 degrees centigrade, and just trying to do this as quickly as I can with some hot iron. See if this flows through. Okay, it seems to be doing. Okay, that's all soldered up. I'm going to turn it down before I forget. Back to my normal 360 degrees centigrade. Okay, so now that that's on and soldered on, I don't actually have any new cement, but what I'm going to do is I'll get some tomorrow, but that shouldn't stop us from testing it. One of the key things to have a look at is, has the solder come through on the top of the board? And it's quite difficult to have a look in. What you want to try to do is have a look, has the solder come up onto the top of the board on each of the legs? And it looks like it actually has. So one of the ways you can test whether the solder's flowed through properly is to put your multimeter into continuity test, which means that when you touch it, it beeps. When there's continuity, it beeps. Cook it on one, you test this little solder joint here, which has got no component in. That's worked. And on the lead just below the odd lead, and it goes to these two, the bottom two plugs, which are for connector J101 is the bottom two pins on J101, which are pins 6 and 7. So if you're getting connectivity between pins 6 and 7 and the lead just below the odd lead, you know that solder's flowed through as well. So look, I think that's pretty good. I'm going to clip these leads off nicely now. So let's get those leads clipped off. Okay, so now note, I have not put the heatsink cement back on. I will go and do that tomorrow. I'm not going to film that. That's just a little bit like placing some fresh heatsink cement on it. Putting it on improves the conductivity between the bridge rectifier and the heatsink to make sure that it cools down effectively. They are screwed in nicely, but just for testing purposes it should work. So let's see how we go, and I'm going to pop it back in the game. So I'm going to turn it on and see if it doesn't go pop. Okay, that looks like it is in a lot better shape than it was before. I'm not quite sure what the test report says. Opto. Suggesting I check all the opto left magnet error. That might just be a function of all the issues that I was having before. Let me close this up and have a game. Putting the balls in might help, so let me get those balls in. And have a game.
Do you believe in destiny? Everlasting love.
So I played that, it's working great. Clearly the bridge rectifier was the problem. Hope this helps. If you liked the video, you can subscribe, else leave a comment, tell me what you liked, what you didn't like. Thanks for watching. That's it for now, until next time.